Okay, all right. Hello, everyone. This is Volts for September 24th, 2025. How to clean up beer brewing and other low-temperature industries. I am your host, David Roberts. About a quarter of the energy the world uses goes to generating heat for industrial processes. I have touched on decarbonizing industrial heat a few times on Volts, but mainly focused on the biggest technological challenge, which is decarbonizing high-temperature industrial heat, 200 degrees Celsius and above. That is, of course, why we love hot rocks around here. But a lot of the energy involved in industry, about 35% of it, and a lot of the greenhouse gas emissions, and crucially, a lot of the local air pollution, comes from more pedestrian, low-temperature processes. Everything from food processing to paper pulping to beer brewing. This category of industry is not primarily a technological problem. For the most part, we know how to replace these industrial boilers with industrial heat pumps, solar and storage systems, and other clean alternatives. Rather, the problem is economic and political. How to organize hundreds of risk-averse businesses across a wide array of markets and sectors to trust and invest in clean solutions that often cost more upfront. It is a thorny problem, but some states and utilities are beginning to tackle it with concerted policy. To discuss what is happening and where, I am joined today by Teresa Cheng, California Director for Industrious Labs, and Richard Hart, who directs industry work at the American Council for an Energy Efficient Economy, or ACEEE, as we call it. We are talking today about what is possible in this sector, what is happening, and what could accelerate progress in the future. All right then, with no further ado, Teresa Cheng, Richard Hart, welcome to Volts. Thank you so much for coming.
Thanks so much for having us.
Happy to be here.
Richard, let's start with you. I kind of want to get the lay of the land, and I sort of gestured at this in the intro, but give us a sort of sense of what are we talking about here? What kinds of businesses are we talking about, and what are they using heat for, and how are they generating the heat? Sort of, what is the problem to be solved here?
Great. Well, if we think about the industrial sector, boilers account for about 30% of all the energy going into US industry. And these boilers are not your standard home hot water heater. These boilers are the size of a large commercial refrigerator all the way up to the size of a semi-trailer. What are they being used for? They're being used for making steam and hot water in every kind of industry you can imagine. So if you walk into a supermarket, everything in the center aisle has at some point been heated through steam. That might be pasteurized products in the refrigerated aisle, anything that's been processed, anything that's been tempered, chocolate, etc., anything that's been in a facility that's been cleaned. In the chemical sector, we're talking about distillation of products. In the pulp and paper, you've got to heat up the pulp to get it ready to be made into paper, etc., etc. Now, if we think about this use, and we're primarily, as you said, talking about this low area, which is up to 200 degrees C, about 390 Fahrenheit. In the pulp and paper sector, about 90% of the heat that they use is in that range. In food and beverage, it's 80%. In chemicals, it's 30%. So this is a substantial opportunity at the low end in sectors that are really prevalent across the US.
And technologically speaking, are we mostly talking about boilers here? Is that the...
Yeah, the main thing I'm talking about here is boilers, because that's, I think, our topic of today is at that low end, all of that heat is being provided by boilers. As soon as you get up into higher temperatures, we're talking about ovens, we're talking about blast furnaces, we're talking about a whole series of large-scale industrial equipment that melts metals, etc.
I just wanted to make the point that the sector, the industries involved here are extremely distributed and diverse, but the technology we're aiming at here is pretty much just one thing, big industrial boilers, right?
That is 100% correct. So let's talk a little bit about diversity. In our projections, there's somewhere around 39,000 of these industrial boilers across the US. It might be 43,000, there are some ranges. About two-thirds of those are pretty small. We say less than 10 million BTUs. So that might be something that is sort of the size of, as I said, a large commercial refrigerator. And then about a third of them are very large. And these would be items you would walk by and you would notice if you saw one of these large industrial boilers. And they're just spread across the chemicals, food and bev, and pulp and paper sectors. That's where the majority of these boilers would be found. One of the things I want to make that backs up the point that you made at the beginning here, David, is let's suppose the average life of a boiler is about 25 years. Some of them have gone to live 60 years, but let's say 25. That would suggest there's about 4% turnover each year, which means if we do the math, it's about 6 purchase orders issued for new boilers every working day.
Oh,
So today,
that's robust.
as we record this podcast, we're midway through the day, 3 to 4 to 5 purchase orders have been issued for boilers right now. So this is an issue where every day is encouraging the deployment of an asset with a 25-year or more lifespan.
Yes, that's the sort of grim way of putting it, but a happier way of putting it is if we intervene and they start replacing these with clean technology, it will turn itself over relatively quickly, right? Within 25 years. So, I guess the question here is, absent extraordinary intervention, if you're just intervening in these decisions, like our boiler's done, we need a new boiler, and you use clean technology instead, just that process, how long would it take to sort of turn the whole, to clean the whole sector up?
I don't have a great answer for the exact length of time. It's a lot of different calculations. I'll just make one point in response to that. We did a research earlier this year, my colleagues Andrew Hoffmeister and Helen Chen, and they calculated that if we just allow boilers to be replaced at their natural end of life, we would expect not to achieve a decarbonized US industry by 2050. So if we have that goal and say, let's assume we want to get to a net zero US industry by 2050, we have to accelerate replacements.
Got it. Interesting. Okay. And in terms of pollution, maybe Teresa, you can jump in here. These things are relatively small, so they're not enormous point sources, but collectively, I think they're a big chunk of greenhouse gases. But also, Teresa, I wanted to hear from you about point source pollution. How dirty are these things? And also, this is very relevant to our discussion. Where are they? Typically, what communities are hosting these things also?
Yeah, I mean, that point is something we really nail home. Individually, these boilers might not be in their community massive, sources of pollution, but cumulatively, they account for a huge amount of pollution, right? If we look at California, for instance, 20% of the state's overall greenhouse gas emissions comes from the industrial sector.
Wow.
Now we know, some of this is from oil and gas extraction and refining, but about half of that is actually from our manufacturing sector. Folks don't think of California as a manufacturing state, but we're actually the biggest manufacturing state in the country.
Oh, interesting. I don't think I knew that.
Right. We don't have and part of that is because you don't see the giant steel mill.
Right.
We don't have the humongous aluminum smelter. What we do have is over 35,000 manufacturing firms across the state. And these are facilities peppered throughout every corner of the state. You have boilers and manufacturing facilities in almost every single county. And these are factories making everything from tortilla chips to roasting coffee, wine bottles, medicine, toilet paper, right? These products that we depend on every day that are used all around the country. And what's unique about California is most of the process heat used to make things here, 80%, is actually low to medium temperature heat.
Interesting.
And so this means that in California, we have a huge opportunity to electrify these facilities in the near term. And when we do this, it's really going to spur the market nationwide.
You made a good point, actually, in some of the documents that you sent that I just wanted to sort of emphasize here in this context, which is if you're a state like California and you have laws about emissions and you want to grow your manufacturing sector, this is the only way to do it, right? Like you can't, like it's different if you're in Mississippi or something and you don't care about pollution, but like in California, you've got a bunch of laws. So if you want to grow manufacturing, you've got to do it cleanly. There's no other way to do it.
Absolutely. And I will say to date, this sector, like the rest of the industrial sector writ large, has largely been considered too hard to decarbonize.
Yeah,
right.
I mean, it is hard. Let's not.
It is hard.
Let's admit it. It's very dispersed and so many different kinds of owners, so many different circumstances. You know what I mean? Like it is a tricky policy problem.
Look, the industrial sector absolutely is hard to decarbonize, but I think what we're really trying to make clear is when we're talking about these facilities using low to medium temperature heat, the technology is out there, right? It's already commercially available. We're not trying to actually innovate here. We're not trying to, create a vaccine in the middle of a pandemic. What we're really trying to deal with is this political challenge of how do we actually get industrial heat pumps, thermal batteries in these factories.
Yes, but that's the harder part. Like, remember, we made the vaccine in 2 days and then botched trying to get it to people. So it's actually the political end of things that is more difficult. I'm sorry, I'm trying to emphasize how hard this is, but like, I think people need to appreciate just because we have the technology, that is like barely step one. There's a lot more steps after that. So Richard, back to you on the technology question. We're mostly talking about industrial boilers here. So when we talk about the technology solutions that Teresa is referencing here that are mature and ready to go, are we primarily talking about industrial heat pumps, or is there more variety in the solutions than there are in the problem?
There are basically three opportunities here. Industrial heat pumps, we believe, is the clearest opportunity in as much as because of the wonders of heat transfer, their efficiencies can be 200 to 500%. Right, so you get you're moving a lot more heat than you're putting electricity into the system.
Can we pause here for a second? I kind of wanted to do I may still do a whole pod on industrial heat pumps because I'm sort of fascinating. But just my audience is relatively familiar with heat pumps. Are industrial heat pumps just larger versions of the same thing? Like if you get how your heat pump works at home, is that basically what's going on with an industrial heat pump, just bigger?
I would say generally yes. There might be two things that we would add to that. The first is, let's just take an example of pasteurizing milk. So you're going to receive milk. In fact, there's an enormous amount of milk made in California, to pick up on what Teresa was saying. Here's milk. It comes to the pasteurizing facility, the bottling facility. The first thing to do is it has to be heated up. Once it's heated up, it needs to be then rapidly cooled so that it can be refrigerated and transported. That pasteurization process requires heat. But guess what? You're also cooling it down. So you're releasing heat from the milk at a later point.
Right.
So there's a circularity of heat inside the system that is very powerful and is not available to your average householder. Right? So your average person at home has got a heat pump, which is just you're basically extracting heat from the air. And now in industrial settings, you've got ready-made sources of heat that you can start recirculating around the system. That's very powerful. And we see that across multiple sectors, by the way. You see that in every part of the chemical sector, there's heating and cooling going on.
And to what extent are these industrial heat pumps bespoke to individual uses versus kind of a standard machine?
Well, both are true, in as much as we see exactly that in industrial settings. There is a standard market for a heat pump as there is a standard market for boilers, and yet we'll find a particular industrial facility that might have a particular temperature range, a particular operating condition, a particular availability of water that they really need to worry about, whatever it might be.
Right.
So there's a variety of circumstances that are going to create customization. And at the same time, there are standard products that are available off the market. And so that's one thing, is the availability of different fluids moving around the facility. There's simultaneous heating and cooling, and that's very, very helpful for heat pumps. The second is your average heat pump at home is really got a very minimal range of operation. Whereas the heat pump in a large industrial facility may have a very wide range of operating temperatures, but also it's got to go way higher than your average home. So the requirements on the equipment are more stringent than you might see in a regular heat pump.
I think I read that, like, what is it? You get to 100C and you start losing efficiency, and then you sort of peter out around 150. Or I made those numbers up, but like, what temperature range do they sort of top out at?
The key question is how much are you raising temperature from what you received to what you're putting out?
Right.
So if you are receiving, let's say, liquid off the pasteurization process that's being cooled, and you're only sort of raising the relative temperature on the way back by 50 degrees C, that's a very different question from it's minus 20 degrees outside and I'm trying to get to 200 degrees Celsius on the inside. So the gap of the temperature, what engineers will typically call the lift, is going to dictate the efficiency of the system. And the smaller the lift, the larger the efficiency. And so that's really the calculation that needs to be made in every single location as to kind of what you're going to get from the installation of a heat pump based on what available fluids do you have and how high do you need the temperature to go.
And here's a question that's difficult to phrase. Is there a sort of clean break between the businesses where industrial heat pumps are big enough to work and the businesses like, say, steel, where you need something much higher? Or is there kind of a fuzzy range in the middle? Do you know what I mean? Like where industrial heat pumps like maybe kind of work, but not quite. Like, is it clear where they do and don't work?
David, if you ask the vendors, you'll get a very much fuzzier answer, I think, because they're always going to be pushing the envelope here. But I do believe that up to 200 degrees Celsius is what we're seeing in the market. And that seems like it's not a physical barrier, it's just simply what's available in the market at this point. And we see vendors consistently pushing up to higher temperatures for their steam. They may need to add on some particular kind of steam generating equipment, but they're sort of out there. And I would say that the one thing about all of this is the mixture of technologies to meet industrial needs and the mixture of business models that the vendors are adopting, it's really varied. So if you want to buy a heat pump right now and say, I don't want any of this fluid heat circulation nonsense. I want to have like my home heat pump. I want to extract heat from the air and send it into my industrial facility. You can buy that. If you want to really get into the circulation of heat, you can buy that. If you would rather not put this on your balance sheet and instead you want heat as a service, you can get that. So the need of the customer is driving a really large amount of, I wouldn't, to build on what Teresa was saying, this is not sort of building something brand new, but it's a lot of innovation in the engineering of the heat pumps to meet the needs of the industrial customer.
Right. Well, I don't want to get stuck on industrial heat pumps,
Sure.
but one more question, which is just technologically, is there a upper bound here that's set by physics? Like how high can we expect industrial heat pumps to get with additional engineering and innovation? Do we have a good sense of how far they might go?
I'm probably the wrong person to answer that question. All I'll say, the key question is there's a fluid that's moving inside the heat pump that's got to be compressed and expanded. And so the temperature range that that fluid operates in is going to dictate how high the outcome from the heat pump can go. And right now, those fluids tend to operate really well up to about 200 degrees C. And then as you go further up, you need to be creating more and more specialized fluids. And clearly, you're not going to be using a heat pump for melting metals, right? So that's not out there as an opportunity. But there are, for example, chemical processes which are running at 400 degrees, and those are managed by steam boilers right now, moving steam around a facility. So that's not out of the realm of possibility.
Right. So at the very least, there's a moving target here.
Yes.
There's innovation happening in the sector. When I was asking about the technologies to replace heat pumps, you said there was some variety. So what are we talking about other than industrial heat pumps? What are the other, like if I just want to decarbonize my low temperature industrial facility, I can have an industrial heat pump. What other kinds of things might I do around that would help?
And at this low temperature range, to continue on that path, electric boilers have been around for a while. There are a variety of different technologies that are available there. The main difference between an electric boiler and the industrial heat pump, there's two main differences. One is the electric boiler is somewhere between a half and a quarter as efficient as an industrial heat pump. So your average steam boiler is operating about 85 to 95% efficiency. That's your top of the line steam boiler right now. So the amount of gas coming in and the amount of steam coming out, you're talking about 95% if you're peak and absolutely operating that boiler exactly as designed, 87, 60 hours in a year. The electric boiler typically gets up to 99%, so it's definitely more efficient. And the other advantage of the electric boiler is it's a little bit more plug and play in the sense that it's got water coming in and steam coming out, or hot water coming out. And if that's how your natural gas-fired boiler is working, or even your coal-fired boiler, you can sort of plug your whole steam distribution system into that electric boiler just without making any changes. Some of the heat pump people allow you to do the same thing, but again, if you wanted to do more of that sort of heat circulation around your facility, then you've got to be a bit more thoughtful. And electric boilers won't allow you to do that piece at all. And then the last piece is, you mentioned hot rocks. So many of the, officially thermal batteries or thermal energy storage,
Yes.
all of those vendors are currently able to provide steam at a decent pressure and temperature. And in fact, they probably are going to move faster into the higher temperatures than the industrial heat pump, because the rocks themselves are often heated up to 1500 Fahrenheit or something like that, right? So you're seeing many of those vendors making a very wise play to deploy in locations where steam is necessary.
Well, I'm curious, for an individual business who's got an industrial boiler, what would that look like if I was using thermal storage instead? Would I be charging that thermal storage? Would I be putting in solar or something to charge the storage? Like, how would that work for a smaller industrial firm?
You would hook up that device to your electric grid.
Oh, just the grid. You just use grid power to...
Just use grid power. And you could supplement it with on-site power if that was available to you.
So I see from the report here that for heat pumps, it says approximately $10 to $30 per million British thermal units. For gas-fired combustion boilers, it's about $7 to $15. So $10 to $30 versus $7 to $15 is a pretty substantial price gap. What explains the price gap? I guess, like, what explains it, and are the reasons for the price gap, could that gap be closed, or is there something, sort of fundamental that's going to make these always more expensive?
There's certainly ability to close that price gap.
Mm.
That price gap is going to be dependent on a few things. One is, if you decide that you just want to do sort of a plug and play, you want to unplug your steam system from your gas boiler and plug it into whatever this new solution is, then that's going to be a relatively cheaper operation. If you need to move heat around between different parts of your facility, then you're adding some additional costs, because now you've got to think about, well, how do I do that exactly? What are the engineering needs? Do I need the extra piping to get the liquid from one place to another, and so forth? So those can be challenges. And really, the average heat pump might be in a different location, or you might need to have a little bit more power allocated into that part of your facility. So there might be some costs of installation and so forth that would start to add to the cost of the heat pump. But it really depends on exactly what problem you're trying to solve, and to some extent how much space you have in your facility for anything that's new.
But just in terms of like face price, heat pumps are way more expensive than boilers, right? So at the very least, you would be calculating making the difference back over time through more efficient operation, right? Like, the price tag is much bigger up front. I'm just guessing that's a problem.
That is true, and the prices are consistently coming down, at least for the base equipment. But what's typically the case here actually is the installation cost is at least as high as the cost of the equipment.
Oh, interesting.
And again, that really depends on how you try and solve the problem. So if you want to try and do more of a plug and play, you'll get less efficiency from the heat pump, but so your operating costs will not be so beneficial, but your upfront capital costs will be lower. And the more sophisticated you try and be, the more complicated your CapEx is going to be and the more efficient you're going to be at the back end.
Right. And also lurking in the background here is a concept I wanted to get out that people need to be familiar with, which is called the spark gap. Because this is something that faces all electrification, is a problem for all electrification, which is that natural gas is frequently cheaper than electricity, and especially in California. We're going to talk about this in a minute, Teresa, but especially in California, electricity costs are high and rising, and gas remains pretty cheap. So that adds to the financial barrier here.
It absolutely does. And, I just wanted to underline one point that Richard made, which is, the costs are high now, but they are coming down. And part of what's going to drive the cost down is increased deployment of this technology. And so that's, where incentives play such a critical role in these early stages of the adoption of this technology. We know that these high capital costs are a barrier to companies adopting clean heat, even though they want to do it. And public funding can help de-risk these early investments. It'll help share knowledge across applications, support innovation. And so that's why we've got a bill in California, AB 1280. It's actually heading to the governor's desk right now, and it looks to renew and expand the main grant program in California administered by the Energy Commission. It's called the Indigo program. And it essentially is a grant program for companies to deploy these sort of technologies.
Kind of what I've been circling around when I'm talking about the price difference is to set up the fact that policy-wise, if you want these to spread faster, if you want to accelerate deployment of these things, it's just a money thing, basically. You got to subsidize them, basically. There's no fancy way around this. You just got to subsidize people doing this until you can bring the cost down and the market becomes competitive, basically. That's, it's not a super fun or elegant solution, but it is, but it does work. So let's talk a little bit about what people are doing to spur these things. Teresa, you mentioned California, this law AB 1280. There was a bit of a fight about this, but it's getting expanded. And this is just what? It just subsidizes, if I'm an individual business, it'll basically just subsidize, it'll take some of the money off the price of the industrial heat pump. Is that it?
So our bill, AB 1280, does a couple things. One of them is renewing the Indigo program. That is a grant program that helps to bring down the capital costs of installing this clean tech. Another part of what the bill does is it expands financing tools for industrial customers as well. So what this is specifically is low-cost loans from the state's Green Bank, sort of replicating the successes of the Loan Programs Office at the federal level.
Yes.
And, we think this bill is especially timely because in California alone, we lost over $500 million for industrial decarb projects.
Yeah, that's true. All that money, all that billions and billions of dollars got yanked back. And now didn't a court just rule that it's perfectly fine that they yanked it back? It's just so disastrous. Yeah, but I was wondering with what money are you doing this?
I think that's absolutely the challenge today, right? Even renewing an existing program takes money to administer. And that's why something that seems really common sense, investing in modernizing our manufacturing sector, keeping jobs in California, creating new jobs, it has required us to build a broad coalition to really move this forward in a year when we have this budget deficit. But I think that's also what's really unique about our campaign and our work and our advocacy to try to clean up this sector is that we've actually been able to build this coalition that we often dream about but don't see enough, right? We've been able to get the state labor trades on board, environmental justice organizations, climate organizations, manufacturers themselves that want to transition. And it's really through this broad tent coalition that we've been able to move this policy forward and outside of all of its policy committees to head to the governor's desk.
Is anybody manufacturing these things in the U.S., the industrial heat pumps? Are they part of your coalition or is there not enough sort of domestic market yet?
Some of the clean tech providers are part of the coalition. This includes Antora, who I know you've had on the pod. They have a manufacturing facility where they're making their thermal batteries here in the Bay Area in San Jose. And then, some of these other companies include B Corp companies that have as part of their mission these sustainability goals. But yeah, we're really seeing a diversity of manufacturers across the state that want to see this transition happen.
To expand on what Teresa was saying, across the US, there's probably 18 or 19 manufacturers now that have a reliable industrial heat pump offering on the market,
Oh, interesting.
and about half a dozen people offering these thermal batteries of one form or another. We have founded something called the Industrial Heat Pump Alliance, and through that, there's a tool that you can use to connect to vendors. And we have, as I say, I think it's about 19 vendors now signed up who can respond to queries about the availability of heat pumps and how to use them in your facility.
Part of the promise of electrifying industry, especially large industry, is that ideally these large loads have some flexibility. So they'll basically become flexibility resources for grid operators, which could be a very powerful tool for grid balance and grid stability. Mostly that kind of discussion is around large industry. I'm just wondering, is there any talk about having these smaller electrification projects, these smaller things, hooked to the grid and responsive to the grid? Is that part of this discussion at all?
It absolutely is. It's critical. We see that flexibility is going to be required to some extent, where the grid is being overloaded all over the place, right? And so
Yes.
it's not just industrial firms, but households and institutions and large buildings are all going to have to participate in some form of flexibility offering across the grid. Otherwise, we're going to essentially over invest in the grid. And here at ACEEE, we are all about energy efficiency. We've always said the first place you want to move is find ways for the demand for electricity and for other energy to be as reduced as possible, eliminate all the waste, be flexible, and that will mean that the investment in infrastructure is optimized.
Yeah, I'm just wondering if there's some way of capturing the value of that to the grid and using that value to subsidize it. Do you know what I mean? Some way for the manufacturers themselves to get some of that value that they're adding from flexibility. Is that part of this program at all, Teresa?
I mean, this is exactly the story that we're trying to tell. So the interesting thing is that the Indigo program was actually created as part of an energy reliability package a couple years ago. This was part of a big budget trailer bill that was in response to grid reliability concerns. We had just had rolling blackouts a couple years before that. So, that package included a bunch of stuff. It included extending gas plants that were scheduled to retire, but it also gave us this great grant program that was all about how do you invest in industrial decarb in a way that's also grid beneficial.
Well, yeah, because this could be, to just sort of like a random person in the audience, this could sound counterintuitive because the problem in California is the grid is already overburdened. There's all these data centers and everything jockeying to get on this precious electric capacity. So it does seem like on its surface, a difficult time to persuade policymakers to support this other giant sector also coming onto the grid. So the idea that this could help rather than burden the grid, I think, is huge.
Absolutely. And look, one of the greatest contradictions about California is that we have all these climate goals. We are a climate leader, but we also have the highest retail electricity rates in the country, right? I think second to Hawaii. And you mentioned the spark gap,
Yes.
The gap between these high retail electricity costs and low wholesale fossil gas prices is very high. I think it's something like 5 times.
Yeah, in some sense, California is the most difficult place to try to encourage this because that gap is biggest.
It's very big. It's hindering electrification across all sectors. But that being said, it doesn't have to be that way. California has this unique problem where we are integrating so many renewables onto the grid as we should be that we're essentially curtailing, throwing away this power, or even paying other states to take it in the middle of the day. And the problem's getting worse. I think the EIA showed that our curtailment has jumped 29% in the last year. So if we can figure out how to develop better rate signals for these industrial customers, we can actually achieve 2 ends, right? One, we can make electrification more affordable for these customers and incentivize them to electrify, but We can also encourage them to shift load to off-peak times to flatten demand. I think you put it in a really concise way in another pod. You said, like, let's figure out how to not add peak to the peak, right?
Yes.
What we need to do is figure out how to actually add demand to times when we're otherwise curtailing clean electricity.
Well, this is a great question because you sometimes hear from large, heavy industry, like steel or whatever, like, we can't be flexible. We need 100% power 24 hours a day. That's our economic model. That's how it works. We have no flexibility. There's a question of how true that is, but similar question to this sort of lower temperature industry. How much flexibility is there here? Like when you talk to these smaller manufacturers, do they say that they can move their load around? Sort of like, what's the capability there? Hey there, everybody. Don't worry, I'm not going to tell you about a new mattress or push a credit card on you. This isn't an ad. There are no ads on Volts. It is supported entirely by listeners like you. If you'll indulge me for a second, I'd like to ask for your support. I started Volts because we're all surrounded by depressing news about climate change and misinformation about clean energy, and it's never been more important to share the stories of the real people on the ground doing the real work of transition, and all the ingenuity and courage and public spirit they are bringing to it. People are hungry to hear these stories, to learn from and find inspiration in them. I've heard from people who changed majors or careers after hearing episodes of Volts, people using it in classrooms and community groups, even state legislators who have passed bills inspired by specific episodes. Sharing these stories matters. It makes a difference. If you have found value in it and want to help me continue doing it, I hope you will join the community of paid subscribers at volts.wtf. It's about the cost of a cup of coffee a month. If you don't like subscriptions, you can make a one-time contribution, leave a review on Apple or Spotify, or just tell a friend about Volts. I am grateful for any and all support. If you're already a paid subscriber, thank you. And now, back to the show. How much flexibility is there here? Like when you talk to these smaller manufacturers, do they say that they can move their load around? Sort of like, what's the capability there?
I can speak at a high level to this, and Richard, you probably want to chime in, but I think manufacturers are particularly set up well here in terms of responding to, load shifting, incentivizing price signals. One is that they have a unique ability, some of them do, to shift some of their production processes, right? They're already doing that. They participate in different demand response programs in California. The other is, they can install behind the meter resources. This is what some of the grant program funding from Indigo has gone to. And then 3, there's tech like thermal batteries that allows for load shifting and is significantly less expensive than a backup lithium-ion battery.
Yes, hot rocks. So this is potentially, this widely dispersed and extremely heterogeneous sector could potentially be a big player in grid flexibility. Oh, one other thing about California, though, let's mention, Teresa, the South Coast Air Quality Management District. Tell us what they did and what's interesting about it.
Yeah, so we call this the South Coast AQMD. And what's really extraordinary is, the South Coast Air Quality Management District, about 17 million people live in this air district. And it's no secret that it has serious air quality issues, right? If you ever fly into LAX, you can see it. And the air district has been in extreme non-attainment with federal EPA standards for several years now. And so they're looking at any way to cut NOx, right? They have an imperative to cut NOx wherever they can. So last year, they passed a zero emissions rule for small boilers. We endearingly call these baby boilers under 2 MMBTU. That rule is charismatically called 1146.2. And that will require about 1 million water heaters and small boilers at their end of life to be replaced with zero NOx heating equipment. So this is going to reduce NOx by over 5.5 tons a day. That's equal to half of all the cars on the road in the region.
So there's a big environmental justice angle here, too. I think it's been sort of implicit here, but like these are people who have suffered a lot from traditional pollution.
This is absolutely an equity and environmental justice issue. And I think what's really important to note about this rule is promptly after it was passed, the gas industry actually sued the air district for passing these rules. And so, we talked about politics.
What is the, can I just, I mean, just out of curiosity, like passing a rule trying to come into compliance with a federal law, what is the basis for a lawsuit against that?
Well, they're essentially using the same basis that they used to overturn the Berkeley gas ban when they tried to pass, a gas ban in Berkeley, and that really hindered a lot of electrification progress across the state. They're essentially suing on EPCA, saying that this is the air district trying to take away your, gas appliance. And the gas industry, they're on a campaign, right? This is a concerted campaign. It's the same law firm that's being bankrolled by SoCal Gas. They sued the state of New York. They lost there too. They lost this case, and now they're appealing.
But these standards are in place. They're law now. And this is not subsidies, right? This is just a law saying when your dirty boiler dies, you have to replace it with a clean law. Did you get pushback from the little manufacturers about the cost of this? How do you talk about the cost, when you're just talking about regulations rather than subsidies? How do you address the cost issue with the subjects of this?
Absolutely. I mean, anytime there are regs, you're always going to get pushback from industry. That being said, air quality regulators do what's called a cost effectiveness test. They look at health costs, for instance. So the American Lung Association released a very good report recently that actually quantified what are the health costs from burning these boilers on public health. We know that burning gas releases a cocktail of these toxic air pollutants. It's giving people asthma, contributing to higher rates of lung cancer, heart disease. People are dying early because of it. And what they found in California was that if we electrified these low to medium heat boilers, we could actually be saving $17.5 billion. And so that's something that we really try to uplift in our advocacy, right? Like there is a cost to our continued dependence on gas.
Sure. Well, I saw in one of the reports, it's like, the cost of an industrial heat pump is higher than the cost of an industrial boiler. But if you factor in the climate benefits, the heat pump comes out ahead, and these days when I read that, I was like, yeah, that and a $1.50 will get you a cup of coffee, So like, it's nice that this produces health and climate benefits, but instead though, unless those can somehow be channeled to the manufacturers themselves, I'm not sure that's going to help you pass the policy. So lots going on in California. We should emphasize, though, there's lots going on across the country here. There's like things going on in numerous states, some of which maybe are worth calling out. I don't know if you guys have any favorites. I thought the Illinois example here was sort of interesting because the standard here is just subsidies. But in Illinois, they have what's called a clean industry concierge, which is not just subsidies, but funding help, strategy help, connection with vendors and other, you know what I mean? Sort of like a service provider. I wonder, either of you, are there other state policies that you feel like are good or worth calling out?
It's a little ironic that the Illinois concierge is part of the EPA funding that actually did go through. So this is federally funded concierge.
They didn't manage to kill this one, huh?
The CPRG, climate protection work, was those funds did go through and are being used. And another great recipient of that is the state of Pennsylvania with their RISE PA program. And they have been deploying $400 million to support manufacturers in Pennsylvania as they look for various technologies to reduce their carbon footprint and improve their efficiency. So that's another example of the same funds moving in that direction. I want to just call out one other thing about California that I think is also generally part of our work here, which is the governor's target of 6 million heat pumps deployed in residential settings is very powerful. When state leadership sets goals, suddenly the government starts to follow those goals all the way through the different agencies. So I think large goal setting has also been very helpful. We've seen that in Colorado. So the policy in Colorado has been very extensively oriented towards reducing climate change. And so we've got a program called GEM, GEMM, which is targeting the 24 largest emitters and asks them, make a plan. Here's your emissions, here's your target. you make a plan. You can make a plan however you want, and just tell us what it is and how much you're paying for it. And then there are programs available for tax credits and grants within Colorado's sort of government financing of this. So there's lots of opportunities to kind of blend good ideas around plans, good ideas around tax credit, good ideas around grants that are available. And this is actually one of those situations, David, where the idea of states as laboratories is really panning out well.
Yes.
So you're seeing lots of innovation here. We could look at Illinois, where the Commerce Commission is, that's the utility commission there, is running a whole future of gas question, really thinking, where are we going?
Yeah, any state where you're trying to phase out gas, this is a big part of that.
Sure.
A huge chunk of that is the industrial part of it.
And so they've had very extensive consultation with all of the utilities, with many of the manufacturers and the associations and residents and all kinds of different advocates. And that's a process that's ongoing and is expected to wrap up next year. But that's another way of thinking about this. Like, what are we going to do with the gas network, and how do we go off it in a reliable way and make sure that manufacturers are not left high and dry and so forth? We could also talk about Massachusetts, where they just formalized their 3-year energy efficiency plans, and those have a carbon component to them. And so the utilities have various incentives and programs available to support manufacturers who want to move in this direction, and goals to help them move in that direction and so forth. So that's another way of thinking about this, is the utilities being very highly motivated. In North Carolina, Duke is about to submit a carbon integrated resource plan that accompanies its overall integrated resource plan. And so that's another way that the utilities have been involved in this whole exercise. And then I'll just wrap up with New York. So New York has a clean energy fund, and that energy fund has been deployed in a variety of ways to support manufacturers and innovation. And we're also seeing heat pump manufacturers show up in New York as sort of making planting facilities in New York. So it's all part of the economic development idea in New York of bringing together manufacturers to supply equipment, providing a program that they call the Heat Recovery Program. There's a challenge, a C&I carbon challenge. So states really are stepping up and providing a variety of different tools to support this transition. And, California is doing a great job, and many of these other states are just doing a fantastic job too.
I'm wondering, Teresa, California's a little ahead of this. I'm wondering, how big of a piece of the puzzle is education here? Like, what is the level of knowledge among small manufacturers about their context and their options and et cetera? Like, is public education a big part of all these state programs?
I would say it is not currently a big part of the state program, but there absolutely is an important role for government to play to do that. There's groups like the Renewable Thermal Collaborative that I think have also done a really excellent job of bringing together clean tech providers and manufacturers, because part of this puzzle is making the economics work, right? In terms of capital costs, operating costs. But just because we get the economics right, that is not going to translate into widespread deployment automatically. I think Richard mentioned this. There's a number of different reasons why facilities are opting to adopt clean heat. And I think if you look at the history of, industrial transformation in the United States, I'm not a historian or an expert on this in any means, clean technologies or just new technologies have taken time to uptake. It's about, changing behavior, changing culture, instilling confidence in the tech.
Yes. I really think people in our milieu over-index on the economics and under-index on these softer kind of social and political dynamics. Like, those matter. Those meter deployment just as much as the economics.
Absolutely. And this is why I think regulations also do play such an important part in nudging these sort of laggards or these last facilities that don't want to adopt this equipment to compliance.
I'll just add, just in terms of that education, one of the things that is particularly interesting, I was just talking with somebody today about industrial leases. And the fact that much of the equipment that is being deployed in industry, big and small, is actually leased because firms don't want to immediately take on the capex cost.
Oh,
So
right.
these leases are expiring all the time, and lease expiration is a perfect time to have this conversation. So the kinds of people who need to understand about these opportunities, it's the finance people, it's all the people who are sort of making leases and developing lease terms and so forth. So there's another group of people, to add to Teresa's point, who, we need a coalition of people who understand the opportunity that's in front of them and can advocate for it appropriately and sort of make the economics work. And if the economics need some innovative financing, well, that's what these lease companies are all about. So that gives them an opportunity to do something kind of creative. We need to talk with people who are the engineers who design plants. And so those engineers are often ahead of the game, right? They're thinking, I've got a new plant, what am I going to put in here? And get them really highly educated on what's going on with heat pumps, etc.
On that, are industrial heat pumps, just in terms of like the size and the sort of operating parameters, are they similar to industrial boilers such that you can yank the one out and put the other one in without big infrastructure changes? Or is this a bigger change to the process than I'm thinking? How much is this just like a swap?
It's a complicated question because it could be a swap. You're going to have to be thinking about, well, how do I get the electricity to that location in my facility? And maybe I need to invest in some electricity upgrades to do that. But it could be a swap. To feed on what Teresa was saying about grid flexibility, some firms are saying, don't yank the gas boiler yet. Keep the new electricity, could be a heat pump, e-boiler, use that at times when the grid electricity is very expensive. Turn the gas boiler on, right? So you're using the gas boiler as backup to enhance
like a hybrid.
like a hybrid. It's not really a perfect long-term solution if your goal is to really eliminate carbon from the equation, but it's a very rational decision by a company that already has a gas boiler that's operating to say, well,
Right.
let's at least use it as backup at times when electricity is expensive. So in answer to that question, can you just yank out one piece of equipment and put a new piece in? Yes, and maybe no, and it's really going to depend on sort of what problem you're trying to solve and what the economics turn out to be.
On a similar line, like yanking out a boiler and putting in an industrial heat pump is a large increment, let's just say, of action, of financing, of whatever. Are some of these state programs, are there ways to fund or encourage or educate people about smaller incremental steps? Like what would those be? Because like a new boiler is a pretty big chunk. Are there smaller chunks?
Well, the most obvious thing that you can do is to be a wise user of heat in your facility. So
Yes, efficiency.
efficiency, thank you. So I think we're always going to say, before you really head heavily into electrification, think about the heat use in your facility. The last thing you need is to over-engineer a new piece of equipment and then realize after a while, wow, we could have shaved 20% off the cost and time of
Right.
this if we'd actually been smarter about the way we're operating, let's say, our steam distribution system. And are we really thoughtfully cleaning out these things called steam traps? And are we thinking carefully about how we apply heat to our process, etc.? So there are opportunities. That's always going to be the lowest cost opportunity.
And I'll just add, when you look at some of these Indigo grantees, right, they have maybe 5 to 6 boilers in their facility. And
Ooh.
the grants are to install heat pumps, not to replace all of these boilers, right, but perhaps to offset some of the gas use from one of their boilers, right? It's essentially helping them de-risk this investment, and it allows them to pilot the technology.
Yeah, get comfortable with it. I wonder what's next. I read Richard, the ACEEE just put out a report about this subject and about Denmark, about about how Denmark is doing this right. And so I sort of was very interested. I was like, well, what does doing this right look like? Maybe we can learn from this. And it's like Denmark has a rational national strategy, a long-term plan, like everybody's on board. I was like, well, that doesn't sound like us. So in terms of what you would like to see, like I think obviously all of us would like to see some sort of coherent national policy, but that doesn't really seem like it's on the table now. So I wonder from the two of you, like, what's next? Sort of, you're sort of bricolaging these state policies together. Are there obvious next steps or policies that you would want, or sort of reachable targets that are next on the agenda?
I mean, I do want to make a point about the federal politics because it's affected California not just in rescinding, all of this money that was going to come to the state for these industrial decarb projects, but you can't underestimate the impact that this federal shift to the right has also had on state politics. And so
Ooh,
what was common sense policy a year ago, right, has now become highly
now it's woke.
politicized. It's become highly politicized. Like we're going to have to fight to win these common sense policy solutions. Talking about the regs, when the South Coast Air District passed those zero emissions rules last year for those baby boilers, the vote was almost unanimous. The chair of the committee that brought that rule, he's a registered Republican. But this was considered a common sense measure to do. But we've seen this shift now. That same air district earlier this year failed to pass rules that would have phased out gas appliances out of homes and businesses. And part of that is, after the election in November, you had all these folks mobilized by the gas industry coming out of every corner of the region. They're flooding the airwaves with disinformation about how they were going to take away your choice, your freedom to have your gas appliances. And the board voted it down in a very contentious split vote. So I think in terms of what's next, we know it's going to take some mix of incentives, regs, rate reform. But to win on these things, we can't have the same strategy of just mobilizing the army of the willing to press on the decision makers. We actually have to expand the tent and build our power. And that's what we're hoping to do. And what we think we have done with this incentive bill, AB 1280, we think it's been a really important vehicle to do that.
Interesting. Richard, any thoughts on what you'd like to see next?
Yeah, I think there is still a massive opportunity and appetite actually for deployment of electrified solutions by manufacturers across the US. And so if you go to the FRED database, the Federal Reserve of St. Louis, and look up, they've got great data. So US industry spent $345 billion on their equipment in Q2 of this year.
Oh, in one quarter.
Right, just in one quarter. One of the things I think that we should be thinking about is what happened in the Big Beautiful Bill. It had a component which fully expenses capital equipment deployment in manufacturing facilities. If you're paying, let's suppose you had a large heat pump and you're paying $3 million for that heat pump, and you're paying 21% taxes, you're talking about a $600,000 reduction in your tax bill that just suddenly came your way. So there are opportunities to use the thinking around this accelerated tax deduction, the amortization piece. There are opportunities to use this with a wide variety of stakeholders here. And I think the industrial market as a whole can move relatively quickly to deploy this capital. There are opportunities, as we mentioned, like 6 boilers have been purchased today. So that means that 6 electrified solutions could be purchased tomorrow. And we are starting to see the momentum growing. We have a map on our website that shows the deployment of electrified solutions. It's incomplete, and we plan to add a good deal more of the opportunities to that going forward. So I think there is plenty of opportunity within the industrial sector as a whole to lead the way here. And we know that manufacturers, just to close, David, the one thing that we did see with the industrial demonstrations program was it was massively, massively oversubscribed.
Yeah.
And so that tells you that people are very interested in this area. Manufacturers want to make progress. I 100% agree with what Teresa was saying about the politics. It is challenging, but any one of these manufacturers is not selling to the government. They're selling to private companies who are buying their milk, private companies who are buying their pulp and paper products, private companies who are buying chemicals, right? So these opportunities are all around, and they are being driven by private enterprise making decisions that make sense for their business. And those decisions are often happening leaning towards deployment of electrified solutions to meet a variety of different business needs.
Yeah, it's very useful to us that those solutions are better. You know what I mean? Like, at least we're not trying to push a rock up a hill. Like, we have better solutions on offer. So it's, in a sense, they're the ones pushing back against history. Well, this is so fascinating. This is like, I focus a lot on technological solutions here on the pod. I'm a bit of a nerd. I love the high-tech stuff. But I really think problems like this are like the meat and potatoes of decarbonization. It's not fancy tech. It's just like, how do you coordinate a large, diverse body of actors to move in the same direction? So it's really great to hear that things are happening and moving in the right direction. Thank you for coming on and walking us through it.
Thanks for having us.
It's been a real thrill, David. I'm a long-time listener and first-time call.
Thank you for listening to Volts. It takes a village to make this podcast work. Shout out especially to my super producer, Kyle McDonald, who makes me and my guests sound smart every week. And it is all supported entirely by listeners like you. So if you value conversations like this, please consider joining our community of paid subscribers at volts.wtf, or leaving a nice review, or telling a friend about Volts, or all three. Thanks so much, and I'll see you next time.